Hey guys, Mrs. Dan's here. So we're on lesson 12 today, and here's what I would normally have displayed on our board. And hopefully you already checked your homework answers, and we should be working on the do now. The do now is actually missing a few pieces of information, so I'm going to do it with you. This triangle should have clearly had a box that shows it's a right triangle, and the sides should have been labeled A, B, and C. So the two sides that are labeled A and B, the ones that form the right angle, those are called the legs of the right triangle. And then that third side that's across from the right angle is labeled C, and it's called the hypotenuse. And what mathematicians have discovered is that it's always true for a right triangle that if you take one of the legs and square it and add it to the other leg and square it, it will equal the hypotenuse squared. So you can watch that video about the basics of the Pythagorean Theorem so that you can see how it's used. And then these three figures, again, they're missing some labels. Let me figure out what those are. 3, 4x. So this is what it should say. So one of the triangles should be 3, 4, and the hypotenuse is x. And then that middle one was a 1, 1, and an x. And then finally, x, 20, and 25. So if we use the Pythagorean theorem on that first one, we would do 3 squared plus 4 squared is supposed to equal x squared. So 9 plus 16 should equal x squared. So 25 should equal x squared. We know that you can square root both sides, and you do a plus and a minus, which means x is plus or minus 5, but since these are sides of a triangle, the sides of a triangle can never be negative. So we always reject the negative when we're talking about sides of figures. So this missing side is 5. On the second one, I would do 1 squared plus 1 squared to give you x squared. So this is 1 plus 1 equals x squared. 2 is equal to x squared. Square root each side, plus minus, but we're going to reject the negative, which means x is equal to the square root of 2. Square root of 2 is irrational. If you did it on your calculator, it would be a crazy decimal. Nowhere in the directions does it say to round, so we're going to leave it as a square root of 2. And that's a general rule that we always follow doing any kind of math problem. If it doesn't tell you to round, don't. Okay, so make sure you just leave it as a square root of 2. And then finally, in this last one, we can do x squared plus 20 squared equals 25 squared. So the key point is knowing which is your C. C is across from the right angle always. Okay, so you have to put the correct number in for C. The A and the B are interchangeable because their squares are being added together, and adding is commutative. So it doesn't matter which one you call A and which one you call B, but C is important. So x squared plus 400 equals, what's 25 squared? So that equals 625. We can subtract 400 from both sides. So x squared equals 225. And if you square root both sides, plus or minus, but ignore the negative because it's a side of a triangle, you get 15. So I just want to point out that the first question and the third question really are similar figures. They're proportional to each other. Do you notice 3, 4, 5, 15, 20, 25? There's a common ratio over here with this third problem. If I multiply all of the sides of the 3, 4, 5 triangle, if I multiply them all by 5, 3 times 5 is 15, 4 times 5 is 20, and 5 times 5 is 25. 3, 4, 5, it's actually a very famous right triangle. It's called a Pythagorean triple. It's so famous because it's not common for us to find sides of a right triangle to all be whole numbers. And then these whole numbers actually are consecutive, 3, 4, 5. It's the only 3 consecutive numbers that make a right triangle. Whenever you get whole numbers for the sides, it is an important triangle, and it is one of the Pythagorean triples. So this is a list of some other Pythagorean triples. Notice in the list we have our 3, 4, 5. I don't think I could write on this. But so we have the 3, 4, 5 right triangle right here. And then another well-known one is the 5, 12, 13. And you can prove that it's a Pythagorean triple by using the Pythagorean theorem on it. If you did 5 squared plus 12 squared, it would equal 13 squared. And then another one that people tend to remember are the 8, 15, 17 right triangle. All the rest of them, you know, it's hard to remember them. And honestly, the one that's remembered most is the 3, 4, 5. So if you can remember 3, 4, 5, if you notice the legs are 3 and 4 and the hypotenuse is 5, you know for a fact that it's a right triangle. And of course, any multiples of that. So 2, 8, 10, or 9, 12, 15, and so on. A 30, 40, 50. So if you wanted to write down the 3 that we talked about, you could, but honestly, you could just test it by using the Pythagorean theorem. So I have an order that I'm doing these problems. We'll do number 1 second. We'll do number 4 first. So this is a right triangle because it's noted with that box in the corner. Remember, the sides that make the right angle are called your legs, and the side across from the right angle is your hypotenuse. So I can call one of the legs A, another leg B, and the hypotenuse is always called C. So this is an isosceles right triangle. Isosceles means 2 of the sides are the same. And they called these are S. I thought those were 8s. Look at that. Side length's S. What is the length of the hypotenuse of an isosceles right triangle with a leg length of 9? So this is a 9, and this is a 9. Write an exact answer. That means we'll have a square root in our answer. And an approximate answer, which means that we're rounding something. So make sure you know what it means for exact and what it means for approximate. So 9 squared plus 9 squared equals c squared, because we're using the Pythagorean theorem. That's the way that you pronounce it, Pythagorean theorem. 81 plus 81 equals c squared. When I add these, I get 162 is c squared. Square root both sides, plus or minus, but ignore the negative. Here's an exact answer. Could that exact answer maybe be simplified? Maybe it can. It didn't tell me to, so I guess I could leave it like that. We should probably practice, though, our simplifying. I'm going to use my calculator to help me with the factors. So 162 divided by x and I'm looking for a perfect square. Oh, look at that, 2 times 81. I should have known that, actually. 81 plus 81 is 2 times 81. So square root of 81 times the square root of 2, 9 rad 2, is the simplified answer to the exact simplified answer. And the approximate answer, you just use your calculator, the home screen even, and do the square root of, we could do the square root of 162, and while we're at it, maybe do 9 times the square root of 2 to prove that we didn't make a mistake when we were simplifying. See how the decimal versions are the same, so I know that I didn't make a mistake. Round to the 10th place would be 12.7. This is rounded. Okay, let's go up to number 1 now. The area of the right triangle is 26.46. So area equals 1/2 base times height. So it comes down to reading very carefully. So if the area is 26.46, I substitute that in place of the area. And they're asking for the perimeter. Well, to find the perimeter, I have to add all 3 sides. So I have to first find the missing sides. All I have is one of them. I guess I could call this the height of the triangle, and over here is the base of the triangle. So I need to substitute in that 6.3, and I'll use a B for base, I guess. It actually could be side B, because C is always across from the right angle. So if we calculate this, so we're going to divide both sides by 3.15. I'll use my calculator for this. I get 8.4. Now 8.4 is this missing side right here. Remember, I'm trying to find the perimeter. So to find the perimeter, I need side C. When you have 2 sides of a right triangle and you want the 3rd side, you should use the Pythagorean theorem. So 6.3 squared plus, I'm going to just do this straight on my calculator, 8.4 squared is 110.25. That's what C squared is, square root both sides, plus or minus, but we ignore the minus. And it says round your answer to the 10th place. So the square root of 110.25 is 10.5. It's also negative 10.5, but it's a side of a triangle, so it can't be negative. Finally, I can answer the question, what's the perimeter? So 6.3 plus 8.4 plus 10.5. .2 inches, and that's the perimeter. So I needed to do all that work in order to finally get the perimeter. So we will have some multi-step questions. I wanted to do number 3 because it's one of those ratio questions. So a 70-inch TV. So when we measure TVs, we measure along the diagonal. So when I call it a 70-inch TV, the diagonal is 70 inches. And the length and the width are in a ratio of 3 to 4. We've done plenty of ratio questions while we're in school. We say that there's a common factor of x between them, so we're going to use a 3x and a 4x for the sides. I don't know if you're noticing something I'm noticing. I won't say it out loud yet. But I could use the Pythagorean theorem because these are the legs of a right triangle, and that's the hypotenuse. So I could do 3x squared plus 4x squared equals 70 squared. Notice how I put the 3x in parentheses and the 4x in parentheses. It's necessary, actually. Get used to always substituting things in parentheses when there's multiple factors that we have to worry about. So this is really a 9x squared plus a 16x squared equals 4,900. I can combine my like terms. 25x squared equals 4,900. Divide both sides by 25. And I get 196. X squared equals 196. Square root both sides, plus or minus. So x equals the square root of 196, which is 14. So x is the common factor. So the common factor is 14. They're asking for the length and the width of the television. So I have to do 3 times 14, and I have to do 4 times 14. So what does this turn out to be? 52 and 56. I meant 42. By 56. And the thing that I notice is that it's a 3, 4, 5 right triangle, actually. What do I want to do next? Number 6. So now I have these algebraic expressions. Something that's missing from here that actually is mandatory is showing that it's a right triangle. The width, find the unknown lengths. This I'll call my A, and this I'll call my B. Remember I said how important it was to substitute things into parentheses. So the x squared, it's only one thing being squared, but if you want to get into the habit, you put the x in parentheses. But this binomial being squared, oh my gosh, so important to have it in parentheses, equals, I'll put the square root of 5 in parentheses and square it. So this is x squared. If you use the box method or the distributive method, we'll get x squared. Well, let me just come to the side here. Remember, I'm doing x times 1 times x plus 1 times x plus 1. So that's what I'm in the process of doing here. X squared plus x plus x plus 1. So I get x squared plus 2x plus 1. And the square root of 5 squared really is just 5. And I want you to think about this. Doesn't squaring and square rooting cancel each other out? So I should be able to say, oh, the square crosses out the square root. I'm left with a 5. Now, if you don't believe me, it said square root of 5 squared, which really is square root 5 times square root 5, which is square root 25, which is just 5. So really, squaring and square rooting really do undo each other. Combine like terms, we have 2x squared plus 2x plus 1 equals 5. I have to solve this quadratic equation. I know it's quadratic because it's an x squared, so I'll get it set equal to 0 by subtracting 5 from both sides. And I have 2x squared plus 2x minus 4 equals 0. I'm just going to erase some of my stuff over here so I have more room. Something I'm noticing is that it's a trinomial, but it does have a GCF. We know many ways now of solving quadratic equations. We could maybe factor. It only works when it's factorable. We could complete the square, but I wouldn't do that if I didn't have to. And we could use the quadratic formula. Now I know that I have to round to the nearest tenth, which is kind of giving me a hint. Don't even try and factor this. So this 2x squared plus 2x minus 4 equals 0. I could try and factor it, but it probably isn't. So I'm just going to use a quadratic formula. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a, where a is 2, b is 2, and c is negative 4. So x equals negative 2 plus or minus square root of 2 squared minus 4 times 2 times negative 4 all over 2 times 2. Use your calculator to figure that out, please. So what I notice is actually I probably could have factored this because under the square root we get a 36, which means our roots are real and rational, right? So this is equal to, running out of room, x equals negative 2 plus and minus 6 over 4. So x is negative 2 plus 6 over 4, or x is negative 2 minus 6 over 4. So negative 2 plus 6 over 4, this is 4 over 4, which is 1. This is negative 8 over 4, which is negative 2. So we reject the negative because you can't have negative lengths. So this side must be 1, and this side must be 1 plus 1, which is 2. So what that means is it was factorable. And I actually want to talk about factoring this then because you guys need some practice. So 2x squared plus 2x minus 4 equals 0. There is a GCF, so let's take that out. And it's a trinomial that can factor into the product of two binomials. Things that multiply to be negative 2 are negative, how about a positive 2 and a negative 1? Because when I do my outers and inners, now I get that 1x. So I set each factor equal to 0. And when I solve, I get x is negative 2, or I get x is 1. Notice the same exact answers that I got over here. Same exact answers. I think this was quicker, but silly me, I saw nearest tenth, and it says if necessary round to the nearest tenth. So maybe I should have given it a shot of factoring before I went straight to the quadratic formula. In the end, it doesn't matter. If you're showing your work and you're getting the right answer, that's great. If it specifically said use the quadratic formula, then you must. And if it specifically said to factor, then you must. But otherwise, you have your choice. Let's go on to the next problem that I wanted to do with you. So that was the fourth. So this is the last one. So an isosceles trapezoid. So an isosceles trapezoid means you have two sides the same. So I just want to label this properly. It says that the length of leg DA is 10 centimeters more than the length of the shorter base CD. So according to my picture, this base is definitely shorter than this base. So the bases are the sides of the trapezoid that are parallel to each other. One is longer, one is shorter. The legs are the things that are congruent to each other. So they want me to call this CD, and the way that we label figures is in the order in the name of it. It's called A, B, C, D. So this must be A and this must be B, because I go A, B, C, D. You have to continue around in the same manner. So leg DA is 10 centimeters more than the length of the shorter base. So I don't know what the shorter base is. I'll call it x. The leg is 10 more, so this is x plus 10. If the legs are congruent, I actually know that this is x plus 10 also. They're congruent because it's isosceles. And the length of the longer base, AB, is 4 centimeters more than, so I'm adding on 4 to something, more than twice CD. CD was x, so twice CD. If the perimeter is 144, find the area. Okay, so I have all 4 sides labeled. Perimeter means add up all sides. So I'm going to go for the perimeter. I'm going to say that x plus 10 plus x plus 10 plus 2x plus 4 is equal to 104. So I am using the information for the perimeter to help me find what x is. If I combine like terms, I get 5x plus 1024 equals 104. Take a look at this. This is linear, right? It's just x to the first power. So linear equations, just do inverse operations. So x is 16. So I just found out what x was. I need to now go find out all of the sides. So this smaller base is 16. 16 plus 10. One of the legs is 26 and the other leg is 26. And the larger base, 2 times 16 plus 4, this turns out to be 36. Yes. So now I know all of the sides. They're asking me, what are they asking me for? Find the area. All right, so area of a trapezoid is 1/2 times b1 plus b2 times the height. So my problem is I don't know the height of this. Because the height is always a straight up and down line, a line that is perpendicular to the base. So I have to first find the height. So do you notice that when I draw the height in, I get this right triangle over here? So I want to do this, I just want to make my trapezoid a little larger. I'm going to use this space up here. You guys should use like a separate piece of paper because you need this space for number 9. So I just want to redraw my trapezoid a little bit larger up here so that I could point some stuff out to you. This was 16, 26, 26, and this whole thing is 36. Now notice when I drop this down, I said it makes a right angle. I could have dropped it down over here also, makes a right angle. But what I notice is when I drop those down, I have this rectangle in the center. Do you notice that this side is 16? Doesn't that mean from here to here is 16? But this whole thing is 36. So what are each of these leftovers then to make it 36? You're right, it's 10. 10, 20, 36. So each of those little pieces is 10. Now I'm going to look at this right triangle that I was talking about. And I'm going to call this x, I guess. I'm going to find, probably shouldn't call it x because the other sides were called x. I'll call it y. I could call it h for the height. That's what I'm going to do. I'll call it h. H for height. So 10 squared plus h squared equals 26 squared. Because a squared plus b squared equals c squared. The 26 is a c because it's across from a right angle. 26 squared is 676. Square root both sides, plus or minus. Ignore the minus because again a length can't be negative, and the square root of 576 is actually 24. So now I can finally fill in numbers into my formula for area of a trapezoid. The area is equal to 1/2 times 16 plus 36, those are the bases, times the height we found to be 24. You can use your calculator for that. You're going to wind up getting 546. It is area. The units were centimeters, so centimeters squared. So the area is 546 centimeters squared. Another multi-step problem. And that's all I'm doing with you. You do the rest, and the answers will be posted another day. Remember to send questions if you have them. See ya. Bye.